All right, Math 47, we are about to start 3 different sections, all with solving equations. So we've done some very basic equations up to this point. They're going to start getting a little more complicated now. So I've typed out up here the procedure for solving all of the equations. Now, we're not going to use every single step in this procedure quite yet, but I wanted to have them all typed out in one place for you. So here we go. The first thing that you're going to do is you're going to remove any parentheses, and you're going to do this by using your distributive property. Now, if you look down at all of our examples that we're going to do in this set of notes, there are no parentheses, so we're not going to worry about that till the next section. Once you remove all of your parentheses, then you combine any like terms that you can on either side of the equal sign. Okay? We're actually going to do that in the last example that we have in our notes here. Then you use the addition principle to get all the terms with the variable on one side of the equation. So what that means is you're either going to add something to both sides or subtract something from both sides. And then you're going to isolate the x by either using multiplication or division. And then sometimes we'll check maybe 2 of our answers here. Okay, so we have lots of examples here to do. So remember, the idea behind solving an equation is you want to get the variable alone. Step 1 is remove any parentheses. There are none. Step 2, combine any like terms. Well, there are no like terms that you can combine on this side. There are no like terms you can combine on the right-hand side, so we don't have to worry about that. So now the next thing that it says is we're going to use either adding or subtracting. So we want to get the y alone. So the first thing we're going to do is we're going to get the 4y alone. How are we going to do that? Well, how do I get rid of adding 7? I'm going to subtract 7 from both sides of my equal sign. So let's see what I have left. On the left-hand side, I have 4y. Those 7's are gone. Equals, and 31 minus 7 is 24. And now we need to isolate the y, get it alone. What's happening? It's being multiplied by 4, so we've done this a billion times. We're going to divide both sides by 4 to get y is equal to 6. All right, let's go on and let's do b. Very similar here. There's no like terms to combine over here, no like terms to combine over there. So we are simply going to start by getting the negative 8x alone. So I want to get rid of subtracting 12. What's the opposite of subtracting 12? It's adding 12, and you add 12 to both sides of your equal sign. These are going to cancel. You have negative 8x on the left is equal to 20 plus 12 is 32. Now we want to get the x alone. Well, right now it's being multiplied by 8, so we're going to do the opposite of that, which is dividing by negative 8. Remember, you always divide by whatever the number is with the x. Those will cancel. And 32 divided by negative 8 is negative 4. Okay, let's look at C. Now notice the y is on the right-hand side. That's okay. If we would rather, we could always exchange sides of the equal sign. So why don't we go ahead and do that? So I'm just going to put 4 minus 2y equals negative 9. All I did was switch sides of the equal sign. No biggie. All right, so I need to get this term alone. So this is a positive 4. Don't say that 4 is being subtracted. That is not true. This is a positive 4. So how am I going to get rid of that positive 4? I'm going to subtract 4 from both sides of my equal sign. So look what we have here. 4 minus 4 is 0. That's gone. And what we have left now is negative 2y. Remember, the sign in front of the term is the sign of the term. is equal to, and negative 9 minus 4 is negative 13. We need to get the y alone, so right now it's being multiplied by negative 2. We're going to undo that by dividing both sides by negative 2. Those will cancel. Y is equal to, okay, here, is 13 divisible by 2? No. So we're just going to leave it as 13 over 2. And in fact, it's going to be positive 13 over 2 because don't forget a negative divided by negative is actually positive. So we're going to leave our answer like that. Remember, you can pause at any time, go back and watch an example. Okay, D is a little bit different. So look, it's different because we have x's on both sides of the equal sign. That has not happened so far. So if you go back and if you look at number 3 up at the top, you can see that it says use the addition property to get all terms with the variable on one side of the equation and the numerical values on the other side of the equation. So basically what that means is you want to get everything with an x to one side and everything without an x to the other side. And it doesn't matter which side you choose. So me, I always like my variables on the left-hand side. So that's what I'm going to do. So think of it this way. If I want all my variables on the left-hand side, then what's over on the right-hand side that I don't want? Well, I don't want the 6x over there because I want all my variables on the left. So how do I get my variables? How do I get rid of this positive 6x? I'm going to subtract 6x from both sides of my equal sign. Well, let's see what that does for us. We have 5x minus 6x, that's negative 1x. We still have the plus 17. But on the right-hand side, these disappear, and I'm left with negative 5. Look what I have. All of my things with my variables are on the left-hand side. Perfect. Okay, but now I want anything that doesn't have a variable on the other side. So what that means is I need to get rid of this plus 17. How am I going to do that? Well, I'm going to subtract 17 from both sides. So I'm going to get negative 1x, these will disappear, is equal to negative 5 minus 17 is negative 22. Now I need to get rid of this negative 1, because remember my long-term goal is to get the x alone. It's being multiplied by negative 1, so I am going to divide by negative 1. And I get x is equal to positive 22. Let's go ahead and let's check this one just to quickly remind you of how to check. So remember to check an equation. You take your answer, you go back up into the very original equation, when wherever you see an x, you're going to put whatever your answer was, which in this case is 22. So it would be 5 times 22 plus 17 equals 6 times 22 minus 5. We hope. Well, let's do the math. 5 times 22 is 110. And 6 times 22 is 132. Okay, well, let's finish this side off. What's 110 plus 17? That's 127. And on the right-hand side, what's 132 minus 5? Gee whiz, it's 127. So it checks. So you can always check your equations. Last one in this set of notes. Now notice how long this equation is. Now remember our steps. There's no parentheses to get rid of, but this is the first one where there is like terms that we can combine on the left-hand side. Look, I've got a 3a plus 1a. That's going to give me 4a. I have a negative 6 and a negative 5. That gives me a negative 11. So now do you see where now E looks exactly the same thing as D? So if you wanted to pause the video and go ahead and do E on your own and then come back and play it and check it, you're welcome to do that. I'm not going to do that. So I'm going to get all my variables on the left-hand side, which means that I want to get rid of the 5a on the right-hand side. How do I get rid of a positive 5a? I'm going to subtract 5a from both sides of my equal sign. So 4a minus 5a is negative 1a. We still have minus 11 equals, those disappear, and we have a 1 on the right-hand side. Now look, all my variables are on the left. So now, what's on the left that I don't want? Well, I don't want this minus 11, so how am I going to get rid of minus 11? I'm going to add 11 to both sides, giving me negative 1a. These will disappear, is equal to 1 plus 11 is 12. The a isn't quite alone yet. Right now it's being multiplied by negative 1. So we're going to get rid of that by dividing both sides by negative 1. And a is equal to 12 divided by negative 1 is negative 12. And we are done with section 7-2.